This is the data types activity. I have the C# README open, but we're going to basically talk about this more generally rather than being specific about C#. We're going to talk through kind of all four languages and programming languages in general. Starting off, objective one is to research the different types, data types, and I recommend doing this for each language and take notes. There are some differences between the languages in terms of the data types that each language provides and how those data types are used. So do that research on your own. If you haven't done that now, pause the video and go ahead and do some research, take some notes, try to learn about the data types. There's a lot of information, there's a wealth of information. It's worth spending some time doing some research. We're going to jump down to objective 3. We're going to talk through these questions now that you're done with your research, right? So starting off with the first question, why would you use each given data type? So again, there are a number of different data types out there, and basically we want to use the data type that most closely matches the data we're representing. So let me create a new file here, and let's just pick C#. So that way we have some code here. We'll do public static void main. And in here, let's talk about some data. So for example, if I had somebody's name, let's say first name, a string is going to make sense. If I have somebody's date of birth, I could certainly do that as a string. Not really my birth date, but this is going to be awkward, right, dealing with this. So as a date, dealing with this as a string means I can't easily get the birth year out or the birth month out or the day of the month out. So this becomes very difficult to deal with data. So in general, we want to use data types that closely match what we're doing. So how we use each one depends on the kind of data we're modeling. If I were going to model somebody's birth date, I would rather use something like a date time if it's provided. And most languages provide something like a date time. So now I could say new date time, or in C# datetime.parse. And now I can read this out and deal with it as a date time itself. So now I can deal with the date object directly. Number 2, what are the readability, maintainability considerations for each data type? So readability and maintainability, this echoes very much with question 1. The readability and maintainability has to do with making sure that we use the right data types for the right data. This is a great example of this. Let me do a counter example. Let's say we wanted to represent a zip code. So zip code in the United States is 5 digits. We won't do the 4-digit extensions. So we'll say zip code equals, and I could do this as 76016, which is the Arlington zip code. And this seems to make sense, but the problem comes when we have the zip codes that start with zeros. So now if I say the zip code is 00109, this is going to be a problem because the leading zeros are going to get truncated when the number gets saved off. So this is an example where zip codes are probably more appropriate stored as strings, so I can keep those leading zeros. There's other ways of dealing with that, but those become maintainability concerns. For the most part, we don't do math on zip code objects. We're not trying to calculate certain things. It's simply a value, especially if you start moving outside of the United States, so you start going to APOs or military kinds of postal codes. Then we're going to start having letters in there, and sometimes even spaces, and sometimes dashes. So having a zip code as a string is going to make a lot more sense. So the readability and maintainability really comes down to using the right data types for the right data that we're trying to model so that it's easy to read, easy to understand, and everything makes intuitive sense. Our next question, what are the performance considerations for each data type? There's a lot of data types here, so we're not going to go through everything, but in general, the smaller the data type, the smaller the footprint. So if we think about our integral data types, they are byte and assigned byte. So byte is 0 to 255, assigned byte is negative 127 to positive 127. So byte, assigned byte. Then we've got a short and an unsigned short. So a short is going to be negative 32,767 to positive 32,767. An unsigned short is going to be double the range starting at 0, so 0 to 65,535. Then we'll have integer and unsigned integer. And alias for a short is going to be int16, just so we're talking the same language. So these are going to be integer and unsigned integer. And then finally we have long and ulong, which are int64 to uint64. So looking at these data types, these can hold a wide array, a wide variety of different numbers. The smaller the number, like byte, the less data it's going to take in memory. So a byte takes 1 byte, which is 8 bits. A short is only going to use 16 bits, integer is going to use 32 bits, so 4 bytes, and then finally the long is going to use 64 bits or 8 bytes. So each number that we store, even if the value is 1, that if that's an integer, that's still going to store it in 4 bytes, even though it's a very small number. So as we're looking at our programs, if a value will only ever have a range in 0 to, let's say, 100 or 0 to 200, then you could you could represent the value as a byte instead of an integer. That is going to minimize the memory footprint. Now, that being said, there are other trade-offs. Most languages have optimizations for specific data types, and most languages prefer the 32-bit integer, and then similarly they prefer the float or the single. This generally performs the best. That's not a universal truth. You'll have to look at your programming language to see, but there are data types that are generally preferred in some languages that are optimized for performance. So our 32-bit integer, the int, is generally the default data type for most programming languages because it's optimized for mathematics at the processor level and the programming level. So that's the idea there. So there are trade-offs. Again, if you have really small sets of data, choose a smaller data type because it'll minimize your memory footprint, especially if memory is a constraint. If you've got, for whatever reason, maybe you're doing something with an embedded system, or you're doing something on a machine that you're paying for the memory, something along those lines, you may want to minimize your memory footprint. But otherwise, performance reasons, there are reasons to use native or default data types, which might be an integer, it might be a single, it might be a double in your programming language. But take a look at those programming languages. Worth doing some research in your specific language to make sure you understand what's going on. What advantages do some data types have over others? This is a bit of a rehash. We've kind of talked about them. So the advantages they may have could be performance. They may be smaller memory footprint. They may be representing the information appropriately so that things make sense. They may be the ability to do math on certain data types. So again, representing them appropriately. So the different data types have advantages as you start talking about the specific cases. But this is a bit of a rehash on the others. How would you create custom data types? Well, the short answer is classes. And basically all of the languages I teach you have classes. You can also use structs, enums, interfaces. So there's different types of types, categories of types that you can create to create new custom data types. But classes is the short answer. A class is a very good way. So for example, you could create a new class called zip code. And now my zip code could have methods to parse a zip code out from a string to represent it as a string. If I needed to see if it had a 4-digit extension, I could do that. I could rename this to postal code instead of zip code, so that way I could represent other postal codes outside of the United States. So lots of different things that I could do with the postal code or a zip code class. So classes are the way that we represent new data types that don't already exist. And then what are some real world scenarios where you might use each data type? Again, a bit of a rehash. Think about this. This is worth thinking about as we go through the different exercises. But we've talked about a lot of these here. So anything that's textual, we're going to store as a string. Anything that represents some sort of date or some sort of time, we'll use a date time, a time. There's a number of different types in each language to represent those different values. We've got integers to represent numbers. We've got singles and doubles to represent floating point numbers. We've got decimals, all sorts of different data types. So think about the data type and how that applies to the real world. The real world, we use classes and data types to model the real world. So there's always a direct relation, there's always a direct correlation, and we can always create new classes to represent the real world. That concludes the data types activity.